Let's look at the properties of functions. We have the domain and the range. We have extremes. We have intercepts. We have variations, which is increasing and decreasing. We have the signs, like when is it positive or negative. We have the axis of symmetry. Domain. These are all x values, and they're in interval notation. We're only looking at the x-axis. And the range are the y values. So they're all y values. They're also in interval notation, and they deal mostly with the y-axis, so we don't have to really worry about the x-axis at all. Let's go and look at some examples. Here we have a graph. It has a beginning and has an end. The domain is all the x values. Starts at 0 and it ends at 33. The domain is x is a member of, excepto bracket, 0 to 33, like that. The range are all the y values. It's starting down here at 0 and it's going all the way up to 42. Y is a member of 0, the lowest y value, up to 42, the highest y value. Close the brackets on that. Let's look at domain and range of a linear function. We have f of x is equal to negative 2/3 x. So that's passing through the origin. The slope is negative 2/3, so move over 3 down 2. This graph goes on forever. The x goes from negative infinity to positive infinity, and we write that as x is a member of the reals. The y values, the lowest y value goes all the way down to negative infinity. The highest y value goes all the way up to positive infinity, or y is a member of the reals as well. Find the domain and range of the function f of x is equal to negative 9 over 4x plus 23. The y-intercept, or the initial value, is 23. And the slope is negative 9 over 4. We move over 4, then down 9. The domain, we can see that the lowest x value, it's going to keep on going this way forever. As we go backwards along the x, notice it's getting higher and higher. It's going from the negative infinity to the positive infinity. We're just going to say x is a member of all the real numbers. And then same for the y, like the lowest value for the y is negative infinity. The highest value for the y is positive infinity. Y is also a member of the reals. And then we press answer to see if we're right. Let's look at parabolas for domain and range. What's the domain and range of the function f of x is equal to 13 over 2 times x plus 10 squared plus 12. We want to find the vertex and then decide whether it's opening up or down. The vertex is negative 10, 12 here. The a is positive, so it's opening up. So it's doing something that looks like this. It's just going to keep opening up forever. Let me show you what it exactly looks like, and you don't need to do this for domain and range. You just have to decide whether it's opening up or down. If it's opening up, then the domain is going to be x is a member of, it's going to keep opening up this way forever and that way forever. So x is a member of negative infinity to positive infinity, or x is a member of the reals. If it's opening up, then the lowest value is the y value of the vertex, or the k. We're starting here at positive 12. Y is a member of 12 to infinity, and then rejecto bracket on that. Just to show you exactly what the parabola looks like, I'm going to put in my negative 10, and then we're going to calculate the positive 12. So I'm going to put in this equation, equal to 13 divided by 2 times, open bracket, the x value. I'm going to click on that. Then we can change the x value and get the different y values for that. Plus 10, we have negative 10 plus 10 is 0, squared is 0, plus 12 is 12. Squared plus 12, we get 12. What happens when it's negative 9? We get 18.5. How about negative 8? 38. Really what it's doing is this sort of thing. Negative 8 and 38 is here. It's going to do the same thing on the other side, like that. At negative 12, we should also get 38. If I put in negative 12, we also get 38. The parabola is doing this. Notice it didn't in any way change our domain and range. We're just seeing a more precise drawing of what it looks like. All possible x values, x is a member of the reals, the lowest y value is 12, and the highest y value is infinity. It goes from 12 to infinity. And then we press answer to see if we're right. Similarly, we'll look at the absolute value function, domain and range. H and k, negative 11 and 2 right there. And then it's going to open upwards. It's going to do something like this. You don't actually have to graph it exactly. You don't have to graph it at all. You just have to know where the vertex is and whether it's opening up or down. This one's opening up. I'm going to put in my negative 11 as the x value, and then we're going to calculate the y value, and it will be 2. Is equal to 9 times absolute value brackets, which are these guys, and then the x value, which is the negative 11 in this case, plus 11, close the absolute value bracket, plus 2. That gives us 2. If we put in negative 10, we get 11. So negative 10 is really, negative 10 is really 11. And then if we put in positive 12, we should also get 11. If we put in negative 12, we should also get 11, which we do. It's doing this sort of thing, and it's just going to keep opening up forever and ever and ever. The domain is x is a member of all the reals. It's going to keep going to the left, and it's going to keep going to the right forever. It's a member of all the reals. Y is a member of, from this lowest point all the way up, from 2, excepto bracket on 2, all the way to infinity, and then close the bracket, rejecto around infinity. Then we press answer to see if we're right. Square root function. Domain and range of a square root function. The vertex is at negative 5, negative 4, which is right here. We'll put in negative 5, and then we'll see that we get negative 4 out, is equal to 4 times the square root of negative in front of a bracket, the x value, plus 5, close the bracket, close the square root bracket, minus 4, and that should give us minus 4. If we plotted negative 4, we would get not a number, because this would become negative 4 plus 5 is 1, and then negative 1, we're taking the square root of negative 1, which we can't. I'm going to go to negative 6. That should give us, when we put in negative 6, we get 0. If we put in negative 7, we get a decimal. Negative 8, we get a decimal. How about negative 9? We get a 4. Negative 9, we get 4. It's going to be curving this way. 1, and then we went 4, and then if we went 9 more than negative 5, negative 14. If we went to negative 14, that would be our next whole number. Right? Negative 14 is giving us 5, 6, 7, 8. It's just going to keep opening like this. It stops here. This is our vertex, and it's going to open up like that. Negative 30 is 16. We're going to get 16, 15, 16, negative 30. It's right here. Our graph is doing this, and it's going to keep going that way forever. The domain is from negative infinity, and then it stops at negative 5. X is a member of rejecto bracket around infinity, negative infinity, comma, and then it stops at negative 5. Negative 5, then excepto bracket around the negative 5. The range, we also have a start and stop. The lowest value for the range is the vertex here. That's negative 4. Y is a member of excepto bracket on negative 4. It's going to keep going up forever to infinity, and then rejecto bracket on the infinity. Then we press answer to see if we are correct. Extremes. Let us look at the extremes. The extremes are the maximum or the minimums. The graph, it looks like this. This would be your maximum. There would be no minimum, because this is going to keep going down forever. If the minimum is infinity, we just say that it doesn't exist, because infinity is not a number. It's the concept that the numbers keep going. It never reaches a minimum. This has a maximum. This is it. This is your maximum. Your minimum would be the lowest point. A graph like this would have a minimum, but would have no maximum. When we're asking for the maximum and the minimum, we're asking for the highest y value or the lowest y value. These are y values only. We're only interested in the y-axis. If the maximum is infinite, like this one, like it keeps going up and up and up, so we can think of the maximum as being infinity. But infinity is not a number. It never reaches that maximum. There is no maximum point. If it's infinity, it does not exist. You can write DNE or none. It doesn't exist. There is no maximum. Let's look at some examples. We're looking for the minimum. The minimum is 10. Doesn't ever go lower than 10. The maximum is 40. Doesn't go higher than 40. Then we press answer to see if we're right. Let's move on to linear functions. We're crossing at 17, and the slope is 3 over 2. Move over 2 and up 3, 1, 2, 3. It's going to go down forever. It's going to go up forever. There is no minimum. There is no maximum. I am going to put null set for both. Let's move on to a parabola. If we graph this parabola, it looks something like vertex is 7, 4. It is opening down. It's going to look something like this. It's just going to keep going down and something like that. To get it exact, I'll just put in my 7 as my x value, and then we'll calculate the y value is equal to negative 14 divided by 3 times, open bracket, the x value, which is the 7 in this case, minus 7, which gives us 0, and then we square that, we get 0, plus 4 will give us the vertex 7, 4. What happens when it is 6? We get a decimal, very close to 0. When it is 5, we have a decimal. 4, we have negative 38. Let's go and plot that, drag it down somewhere around here. Negative 38 would be right about here. We are 3 steps away from the vertex. If I go 3 steps on the other side, 1, 2, 3. At positive 10, we should also be at negative 38. If I put positive 10, we're also at negative 38. This is what your parabola looks like. It has a vertex at 7, 4. It's opening down. It has a maximum, but it doesn't have a minimum. The minimum is none. The maximum is positive 4. And then we press answer to see if we're right. Absolute value, maximum and minimum. Same sort of thing. We're looking for the vertex, which is positive 8, negative 8 here. It is opening up. I'm going to do something that looks like this. So it's just going to keep going up and up and up and up and up. Let me get the exact values. X is positive 8. The y value is 22 divided by 3 times the absolute value bracket. X value minus 8, which gives us 0. Absolute value of 0 is 0. Take away 8 gives us negative 8. I didn't use the absolute value bracket there. When it is 7, we get a decimal. When it is 6, decimal. When it is 5, we get 14. But 5, we have 14. 5 is 3 on the opposite side of 8, so 3 more is going to be 11. 11 should also give us 14. 11 gives us 14. But it looks like this, and it's just going to keep going up and up and up and opening up like that. It does have a minimum. The minimum is negative 8, but there is no maximum, none. And then we press answer to see if we are right. Let's look at a square root function for maximum and minimum. This is going to have a vertex at negative 3, 8 right here. It is opening in the positive direction, so it's going to curve up like this. Let's go and find some values. When we have negative 3 is equal to 6 times the square root of the x value plus 3, close the square root bracket. That gives us negative 3 plus 3 is 0. The square root of 0 is 0, plus 8 gives us 8. What about at negative 2? We get 14. So negative 2, 14, and then so it's going to be curving this way. It looks like a straight line because we've only plotted 2 points. Negative 1, decimal, how about 0? Decimal, how about positive 1? We have 21, we get 20, which is here. It's curving this way, and it's going to keep going that way. At positive 6, we get 26. So it's just going to keep coming this way. It's going to keep curving. We have a minimum, but it's going to keep going up and up and up and up forever, so there is no maximum. The minimum is 8. Smallest y value is 8. The highest y value is infinity, which isn't a number, but we're saying that there is no maximum. It's just going to keep going up. None. And then we press answer to see if we are right. That's it for maximum and minimum. Let's move on to intercepts. We have x-intercepts where it crosses the x-axis. This is where it crosses the x-axis. These are also called zeros. It's when the y value is 0. When we're talking about functions, we're always talking about what's the y value, what's the function equal to, and when is the function equal to 0? When is the y value equal to 0? Where it crosses the x-axis is when the y value is 0. X-intercepts are called zeros for that reason. There can be many. Here we just have one. We're going to look at some examples where there are many zeros. You could have 1, or you could have no zeros. It's where it crosses the x-axis, or when the y value is 0. You can find it algebraically by setting the y equal to 0. Y-intercepts, it's where it crosses the y-axis, right here. These are called the initial values. If you're looking at a straight line, we call this the b if it was in a straight line. This is called the initial value. It's when the x value is 0. If you have a function, there's only one initial value. You can only ever have one y value if you have a function. It's where it crosses the y-axis. It's when the x is 0. You can find it algebraically as well by setting the x to 0. Whenever x is equal to 0, this is when you get your initial value, or the y-intercept. Let's look at some examples of this. Graphs. Let's look at the zeros first. Here we have a 0, and there we have a 0. click on that just to zoom in a little bit, just so we can read exactly where that is. Our first 0 is at 9. And then I'm just going to move this along like that. Our second 0 is at 81. 81. Then we press enter to see if we are right. Okay, let's zoom out and have a look at what that really looks like. Here is our 9, and here is our 81. And notice it doesn't actually have to go all the way across, but it has to touch the x-axis. It's where it crosses the x-axis or touches the x-axis in this case. And then we press answer to see if we are right. Let's go and look at the y-intercept for graphs. Where does it cross the y-axis? You can see it's crossing the y-axis at 40. The y-intercept is 40, and then we press answer to see if we're right.
Let's look at the zeros first. Here we have f of x is equal to negative 16x plus 20. The b value is 20. The slope is negative 16 delta x over 6 and delta y down 1. This is our graph. It is crossing the x-axis at 120. We can read it off like that, or we can do a calculation. To get these zeros, or the x-intercept, we're going to set the y value to 0. Negative 1 divided by 6 is negative 0.16 repeating. X plus 20. I want to get rid of this 20. I'm going to subtract 20 from both sides. That gives me negative 20 is equal to negative 0.16 repeating. Then to get rid of the negative 0.16 repeating, which is multiplying the x, I'm going to divide it. If I divide on the right-hand side, I have to also divide on the left-hand side to keep everything balanced, and that gives us 120 is equal to x. The x-intercept is 120. Press answer to see if we're right. Let's look at the y-intercept. Let's graph this quickly. The b value is 10, which is the y-intercept. 10. Slope is positive 1/2. Go over 2 and up 1. We can see that it is crossing at 10. All right. If we set the x to 0, we get y, or f of x, is equal to 10. 10 is our answer. Parabolas. Let's look at the x-intercept. Graph this quickly. Our vertex is negative 1, 8 there. It's opening up. It's going to do something like this. It's not going to cross the x-axis. Let's have a look at exactly what it looks like. When x is negative 1, the y value is equal to 28 divided by 3 times open bracket. The x value, which is negative 1 right now, plus 1 is 0. Squared is still 0. Plus 8 is plus 8. When the x is 0, we have 17.3 when it's 1, we have 45 when it's 2, we have 92. At 2, we get 92. That's 3 steps away from the vertex. 1, 2, 3. Go through on the other side. 1, 2, 3. Negative 4, we should also have 92. Put a negative 4, we also have 92. This is what your parabola looks like. It's opening up. There are no zeros. Did we have to graph this exactly? No, we could have just. Okay, the vertex is here. It's opening up. There are no zeros. None. And it has a vertex of 0, positive 7. It is opening up. We're not going to have a 0. The vertex is at negative 11, negative 6 here, and it's opening up. We're going to have 2 zeros. Let's see exactly what this looks like. When the x is negative 11, the y value should be negative 6, is equal to 12 times open bracket the x value plus 11. Negative 11 plus 11 is 0. Squared is still 0. Minus 6 gives us minus 6. When it is minus 10, we get positive 6. Minus 10, we have positive 6. And how about minus 12? We should also get positive 6. We do get positive 6. Looks like this. We can see our 0 is negative 10 point something and negative 11 point something. We're going to have to use algebra to figure that out. Here's our function. We're going to set the y to 0. That gives us 0 is equal to 12 times open bracket x plus 11 all squared minus 6. I want to get rid of the minus 6. I'm going to add 6 to both sides. That gives us 6 is equal to 12 times x plus 11 squared. I want to get rid of the 12. It's multiplying the bracket, so I'm going to divide both sides by 12. 6 divided by 12 is 0.5. 0.5 is equal to x plus 11 squared. I'm going to take the square root of both sides to get rid of the square. That's going to give us plus or minus the square root of 0.5 is equal to x plus 11. Get rid of the 11, subtract 11 from both sides. That gives us negative 11 plus or minus minus the square root of 0.5. Negative 11 plus or minus, so I'm going to do minus the square root of 0.5. And that gives us negative 11.707. I'm going to fill that down to get the positive plus or minus the square root. I'm going to do the plus square root right there. That gives us negative 10.29. There's the negative 10.29 is right here. Negative 11.707 is right there. And then we press answer to see if we are correct. That's how to find the zeros or the x-intercepts of the parabola. Parabola y-intercept. The y-intercept is where it's crossing the y-axis. Let's graph its vertex is at 2, 1 there. It is opening down. It's going to cross somewhere around here. Let's have a look at exactly where. Starting off with 2, and the x is 2. Let's see what the y value is. It should be 1. Is equal to negative 9 times, open bracket, the x value minus 2. 2 minus 2 gives us 0. All squared is 0 plus 1. It's 1. Let's see what happens when it is 0. We get negative 35. It's going to cross down like this. When it is, let's go 2 on the other side. Our parabola is going to look like this. The y-intercept is negative 35. Negative 35. Then we press answer to see if we're right. All right, let us move on to the absolute value zeros, or the x-intercepts. This has a vertex of negative 7, 5. It is opening up. It's not going to have any zeros, so it's just going to be doing something like this, and it's just going to keep going up forever. Let us figure out exactly what it looks like. You don't need to do this. Negative 7, the y value is 8 times the absolute value of the x value plus 7, which is negative 7 plus 7 is 0. The absolute value of 0 is 0 times 8 is still 0, plus the 5 gives us 5. When it is negative 6, we have 13. Negative 6 is 13. Negative 8 should also be 13. Okay, so this is exactly what it's looking at like, and it's going to keep going up and up and up and up. The answer should be that there are no zeros. I'm going to write none. You could also put null set or empty set that and press answer to see if I'm right. All right, let's do one more. When the vertex is positive 5, positive 4, it is opening down. This is above the x-axis, positive 5, positive 4. It's opening down. It's going to look something like this. What's it going to look like exactly? Let's figure that out. When x is 5, the y value should be 4, is equal to negative 8 times the absolute value of the x value minus 5, which gives us 0, times 8 is 0, plus 4 gives us 4. When it is 4, we have negative 4. And when it's 6, we should also have negative 4. We need to find these two values, which looks like 4.5 and 5.5, but let's figure that out exactly. We're going to have to do that algebraically. We set the y value equal to 0. That gives us 0 is equal to negative 8 times the absolute value of x minus 5 plus 4. I want to get rid of the plus 4. Subtract 4 from both sides. That gives us negative 4 is equal to negative 8 times the absolute value of x minus 5. I want to get rid of the negative 8. That's multiplying the absolute value brackets. We divide both sides by negative 8. That gives us 1/2, or 0.5, is equal to the absolute value of x minus 5. I want to get rid of the absolute value brackets. When we're taking the absolute value of x minus 5, we're getting 0.5. That means that x minus 5 to start with was either 0.5 or it was negative 0.5. Put plus or minus in front of 0.5 is equal to x minus 5. We have to introduce a plus minus whenever that happens. I'm going to get rid of that negative 5 by adding 5 to both sides. Our answer is 5 plus or minus 0.5. Our smallest one is 5 take away 0.5, which is 4.5. The bigger one is going to be 5 plus 0.5, which is 5.5. Then we press answer to see if we are right. Let's go and look at the y-intercept of the absolute value function. The y-intercept is where it crosses the y-axis, and there is always going to be 1 for the absolute value function and for the parabola. The vertex is 3, 5. 1, 2, 3, 5. It's opening down, it's going to be somewhere around here. All right, let's see what that looks like exactly. I'm going to put my 3 as my x value. Then we'll calculate the y value, and it'll be 5. It's equal to negative 22 divided by 3 times the absolute value of the x, take away 3, which is 3, take away 3 is 0. 22 over 3 times 0 is 0, plus 5 gives us 5. Let's see what happens when it is 0. We're going to get negative 17. Negative 17 like that. That's our answer. Notice we moved over 1, 2, 3 to get to 17. So if we move 3 on the opposite side of that vertex, 1, 2, 3, we're also going to be at negative 17. When x is positive 5, we have negative 9.6. When x is positive 6, we have negative 17. The answer is, the y-intercept is negative 17. It's crossing the y-axis at negative 17. Negative 17. And then we press answer to see if we're right. The square root function, the zeros of the square root function. And this is an instance where we might not have one. We're going to have to do the calculation. Let's look at where the vertex is first. The vertex is negative 4, negative 6. The b is negative, so it's going to be going this way, but the a is positive, so it's going to be whoop, up like that. We know it's going to have a 0. Let's see what it looks like. When x is negative 4, we should get negative 6, is equal to the square root of negative 1 times open bracket the x plus the 4, close the bracket, close the square root bracket. So that's going to give us negative 4 plus 4 is 0, times negative 1 is still 0. The square root of 0 is 0. Minus 6 gives us minus 6. It's opening that way. If I put in negative 3, it should give us not a number. So it's going to be taking the square root of a negative. So negative 3 plus 4 is 1. Minus 1, the square root of minus 1, imaginary number, doesn't exist. How about negative 5? We end up getting negative 5. But negative 5, we have negative 5. At negative 8 gives us negative 4. This is what it's going to look like. Eventually, we're going to get to it's going to cross the x-axis. Here, let us try 9 more than negative 4 is negative 13, is negative 3. X squared is 25. That's going to give me negative 29. Put in negative 29 here. I get negative 1. Negative 29, I get negative 1. Let's graph that. Let's go 36. Or that's negative 40. At negative 40, we get 0. Coincidentally, we're actually finding the 0. At negative 68, we're getting 2. Square root function looks like that, and it's crossing at negative 40. We could also do this algebraically. We set the y value to 0 to find our zeros. I want to get rid of the negative 6. I'm going to add 6 to both sides. That gives me 6 is equal to the square root of negative x plus 4. I want to get rid of the square root. I'm going to do the opposite of square rooting. I'm going to square both sides. If I square the 6, I get 36. If I square the square root, it's gone. We have 36 is equal to negative x plus 4. Then I want to get rid of this negative. I can just divide both sides or multiply both sides by negative 1. And that gives me negative 36 is equal to x plus 4. I want to get rid of this 4, so I subtract 4 from both sides. That gives us negative 40 is x, negative 40. And then we press answer to see if we're right. Let's look at the y-intercept of the square root function. The vertex is negative 3, positive 1. Negative 3, positive 1. It's opening up. It's going to do this sort of thing. We don't always have a y-intercept. In this case, we do have a y-intercept. Let's see what this looks like. When x is negative 3, the y value, when x is negative 3, the y value must be 1, is equal to 5 times the square root of the x value, which in this case is negative 3, plus 3 gives us 0, the square root of which is 0 times 5 is 0, plus 1 is plus 1. When the x is 0, the y is 9.66, which is our answer. 9.660254. That's our answer. Let's get some other values just to see what this looks like. When x is 1, we get 11. 1, we have 11. At negative 2, we have 6. Negative 2 and 6 is right here. So it's going to look like this. And here we can see that 9.66 does make sense. Let's try positive 2. The next one would be 9 more than negative 3. Negative 3 plus that. But 6, we're going to get 16. Then if we went 16 more, that would give us 13 and 21. It's going to keep opening this way. And we can see that the y-intercept is 9.660254. And then we press answer to see if we are right. All right, and that's how we find the y-intercept of the square root function. And that's it for x and y intercepts. Variation is increasing and decreasing and being constant. This is always given in an interval notation on the x. The y values are increasing, the y values are getting higher when x is doing this, or the y values are decreasing when x is doing this. These are x values and they're always in interval notation. Let's have a look at an example. Here we have a graph saying find the interval where the graph is decreasing. It's going up, up. Here it's going down, down, and down. It's decreasing from this point, which looks like 15, and we can always magnify that from 15 until 48, 15 to 48, when x is a member of 15 to 48, and then excepto bracket on that, and then we press enter to see if we're right. Find the interval where the graph is constant. Here it's constant from 0 until this point. This is 36. When x is a member of 0 to 36, close the excepto bracket, press answer to see if we're right. Let's look at a linear function or a line. Find the interval where f of x equals 12 is decreasing. F of x equals 12 is this. It's never decreasing or increasing. Empty set, null set, and then answer. 1/4 x plus 23 is decreasing. Once again, never going to be decreasing. 23 is right here. The slope is 1/4. Move over 4, up 1. It's increasing forever. When is it decreasing? It's never decreasing. All set. F of x is 1/6x plus 14. The slope is over 6, up 1. When is it increasing? It's always increasing. When x is between negative infinity and positive infinity. The easier way of saying that is when x is a member of the reals, and then we press answer to see if we're right. Let's go and look at the parabola for increasing and decreasing. The vertex is -2, -1. It is going down like something like this. Keeps going down forever. Let's see what it looks like exactly. You don't have to graph it exactly because we know when's it increasing? It's on this arm from here to the vertex, and then it's decreasing. And say from negative infinity to -2. X is a member of rejecto bracket negative infinity to -2, and then excepto bracket on the -2. That's our answer. We don't have to graph it exactly to get our answer, but I'm going to graph it exactly. You don't need to. When x is -2, y must be -1. So let's calculate, see that it is -1, is equal to -7 times, open bracket, the x value, which is -2 plus 2 is 0, squared that in brackets. It still gives us 0, times -7 is 0, minus 1 is -1. When x is -2, we get -1, which is the vertex. When x is -1, we get -8, -8. When x is -3, we should also get -8, like that. And when x is -4, we're going to get -29. When x is 0, we're also going to get -29. -29. This is what our graph is looking like, and when's it increasing? It's increasing on this arm from negative infinity to this point, this x point, -2. All right, and then we press answer to see if we are right. The vertex is 12, -1, like that. It is opening up. It's going to do something like this. When's it decreasing? It's decreasing from negative infinity up until this vertex, when x is a member of rejecto bracket negative infinity until this is +12, excepto bracket on that. But once again, this is not the exact parabola. When x is +12, the y value should be -1, is equal to 34 divided by 3 times open bracket, the x value, take away 12, close that, square all that, take away 1, that gives us -1. Then when x is 10, we really get 44.33. Let's look at when it's 9. Let's look at when it's 9, we're getting 101. At 15, we're also going to get 101. 9, we have 101. And at 15, we also have 101. This is exactly what it looks like. They want to know when is it decreasing, and it's decreasing along this branch until it gets to here. It's going to keep going this way forever, from negative infinity until +12. Then we press answer to see if we are right. That's increasing and decreasing on the parabola, and then very similarly for the absolute value function. Find when this is decreasing. My vertex is 612, like that. It's opening up. It's going to be doing something like this. Okay, let's go and find exactly what it's doing. When x is 6, the y value is 7 times the absolute value of the x. Take away 6, which gives us 0, plus 12 is 12. 6, 12. At 5, we're getting 19. At 7, we should also get 19, but it's going to be opening up like that. When is it decreasing? So it's decreasing along this arm from negative infinity until 6. X is a member of rejecto bracket, negative infinity to 6, accepto bracket, and that's our answer. Let us quickly look at increasing and decreasing square root function. The vertex is -4, -1. The b is negative, the a is positive. It's going to be doing something like this. It's always decreasing. Let's have a quick look at that. When x is -4, we should get -1 as an answer, is equal to the square root of, now the a is +1, it's like the 1 in front of this square root. That's how I know the a is positive. The b is this -1 in front of this bracket. The square root of -1 times bracket x plus 4, which is -4 plus 4 is 0, times -1 is 0. The square root of 0 is 0. And then -1 gives us -1. When x is -5, we're going to get 0. When x is -8, we're going to get 1. It's opening like this. It is always decreasing. So when's it increasing? Never. I'm going to put null set. Find the interval where this is decreasing. The vertex is -6, -4. It is opening, the b is positive, so it's opening this way to the right, but it's opening down to the right, so it's going like that. Let's graph it, see what it looks like. When x is -6, the y value must be -4. Is equal to -4 times the square root of the x value, which is -6 plus 6, giving us 0. The square root, which is 0, times -4 is 0, minus 4 is -4. When the x is 0, we have -13 point something something. When it's 3, we end up with -16. All right, 3 and -16. When it is -2, we end up with -12, is right there. So it's looking like this. When is it decreasing? Well, it's decreasing for its whole existence. So it's going to keep going down like that. From -6 to infinity. When x is a member of, accepto bracket, -6 to infinity, and then rejecto bracket on infinity. Let's look at when this is increasing. This is opening up. It's opening to the right. It's increasing from the vertex to infinity. All right, the vertex is at 3, -3 right here. It is opening like this. Let's find some values. At 3 and here is equal to 6 times the square root of the x value, which is +3 minus 3 is 0. The square root of which is 0 times 6 is 0. Minus 3 is -3. It's opening this way. If we went to 4, we would have 3. At 7, we end up with 9. It's going to keep opening this way. 12, we end up with 15. It's just going to keep opening this way. When's it increasing? It's increasing in its entirety, its domain. When x is a member of the h, which is 3, accepto bracket on the 3 to infinity, and rejecto bracket always on the infinities. And then we press answer to see if we're right. When is this one decreasing? It's opening down and to the right. The vertex is at 0, -2. It's opening down with something like this. Let me plot the actual points. 0, when x is 0, we end up with -2, is equal to -7 times the square root of the x value. -2 gives us -2. At 1, we have -9. At 4, we're at -16. At 9, we're at -23. It's just going to keep opening this way. When's it decreasing? It's decreasing when x is a member of 0, from 0 to infinity, rejecto bracket on the infinity, and then press answer to see if you're right. So that's it for increasing and decreasing. That's variation. Let's look at the signs. The signs are like, when is your graph positive, or when are the y values positive? When are they negative? This is interval notation. And once again, it's on the x. So we're looking at the y values when the x are in a given range. X values Find the interval where the graph is positive. We can see it starts off positive, then it becomes negative here, and then positive from here to here, and then negative, and then positive again. So it's going up and down. When x is a member of, I'm just going to expand the x-axis so we can read the values easier. It's positive from 0 to 6 when x is a member of 0 to 6, excepto bracket on that. And then it's positive again from 20 to 25. I'm going to put a union here. Union from 20, excepto bracket 20 to 25. And then it's positive again up here from 39 until we get to 45. I need another union from 39 to 45. 39 to 45. And then we press answer to see if we're right. When's it negative? From here to there, from here to there, and then from there to there. When x is a member of, from this point, which is 2 until 9, with excepto brackets, 2 to 9, union, and then it's negative from 27 to 32. Then, union again, it's negative here, from 37 to 39. And then we press answer to see if we're right. Let us look at linear functions. When is this function positive? The b value is 24 and it's increasing. It's increasing. The slope is 1/4. Move over 4 and up 1. It's positive. Everything we can see is positive. If we keep going this way, eventually it's going to be negative. We need to find the 0. We can set the y to 0, solve it algebraically, which gives us negative 24 is equal to 1/4. Multiply both sides by 4, negative 96. It is positive from negative 96 to infinity when x is a member of negative 96 to infinity. And remember, infinity gets rejecto brackets because it's not a number. You can never reach it. Then I'm going to press answer to see if I'm right. Here we have negative 9/4 x plus 48. When's it negative? 48 is our b value. The slope is negative 9 over 4. I'm moving over 4 and then down 9. 2, 3, 4, 7, 8, 9. We want to know when is it negative. We need to know when it crosses the x-axis. We have a nice decimal here. We set the y value to 0. Negative 9 divided by 4 is negative 2.25, negative 2.25 x plus 48. I want to get rid of that 48, subtract 48 from both sides. That gives me negative 48 is equal to negative 2.25 x. Divide both sides by negative 2.25 because it's multiplying the x. That gives us positive 21.3 repeating. Negative 21.3 repeating. That makes sense. Positive 21.3 repeating. X is a member of from 21.3 repeating to infinity. And then we put the excepto bracket around that. This is where it is negative. We press answer to see if we are right. At a parabola, we want to find the interval where f of x is less than or equal to 0. Like, when's it negative? The vertex is at 12, 12. It is opening up. We want to know when it is negative. And if it's opening up, it's going to look something like this. And it's never going to be negative. Let's graph that exactly. You don't need to. I'm going to put in 12, and we should get 12 back, is equal to 15 divided by 2 times, open bracket, the x minus the 12, close the bracket, square that, plus 12, and that gives us 12. At 10, 42. It really is going to look more like this. And 14 should also give us 42. 13 gives 19.5, and 14 gives us 42. We're asking, when is it negative? Well, notice it's never negative. So we're just going to put null set like that, and then press answer to see if we're right. The vertex is 6, negative 11. It is opening up. It's going to look something like this. We have to find the zeros. Let's find out exactly what it looks like. When x is 6, y should be negative 11 is equal to 10 divided by 3 times open bracket, the x value minus 6, which gives us 0 so far. Squared is 0 minus 11 is negative 11. At 5, we have minus 7.666. At 3, we have 19. When x is 3, we have positive 19. 9 should also give us 19. Problem looks like this. We're going to have to find the zeros exactly. 4 point something, something, something. And 7 point almost 8. Let us algebraically calculate those zeros. We set the function to 0, or we set the y value to 0. 10 divided by 3 is 3.3 repeating. We We have x minus 6 all squared minus 11. I want to get rid of that minus 11. I'm going to add 11 to both sides. That gives us 11 is equal to 3.3 repeating times x minus 6 all squared. I want to get rid of the 3.3 repeating. So I'm going to divide both sides by 3.3 repeating. When I do, we have 11 divided by 3.3 repeating gives us 3.3. 3.3 is equal to x minus 6 all squared. I want to get rid of this squared. I'm going to take the square root of both sides. That gives me a plus or minus the square root of 3.3. Then to get rid of the negative 6, I'm going to add 6 to both sides. That gives me 6 plus or minus root 3.3 equals 6 minus the square root of 3.3, which gives us 4.1834. That makes sense. Then fill that down and change the minus square root to plus square root. And that gives us 7.81, 567.81. That also makes sense. When is this negative? Well, it's negative between these two values. When x is a member of, from this number, 4.18341 to 7.81, 7.81659. Put acceptable brackets on either end, and then we press answer to see if we are right. It's negative from here to here. Let us go and quickly look at intervals of positive and negative for the absolute value function. When is this function negative? The vertex is -8, -4. It is opening up. It's going to look something like this. Let's see what exactly it looks like. We're going to have to get these zeros. When x is -8, y value should be -4, is equal to 28 divided by 3 times the absolute value of the x value plus 8. Close the absolute value. That is 0, like 28 over 3 times 0. The absolute value of 0 is 0. Minus 4 is minus 4. When x is -5, we get 24. When x is -11, we also get 24. Our function looks like this. We're going to have to calculate the zeros algebraically. We set the y value to 0. 28 divided by 3 is 9.3 repeating times the absolute value of x plus 8 minus 4. I want to get rid of the minus 4. I'm going to add 4 to both sides. That gives me 4 is equal to 9.3 repeating times the absolute value of x plus 8. Divide both sides by 9.3 repeating, and that gives us 4 divided by 9.3 repeating gives us 0.428571, 42857, so it's repeating decimal, 0.428571 repeating is equal to the absolute value of x plus 8. When we take the absolute value is positive 0.42857. The thing inside the bracket could have started off being positive 4.2857, or it could have been negative 0.42857 repeating. We put a plus and minus in front of it when we remove the absolute value brackets. Then I want to get the x alone. The 8 is stopping that, so I'm going to subtract 8 from both sides. That gives me -8 plus or minus 0.428571 repeating, -8 minus, and that gives us, I need equals in front of that, and then let's fill that down, and I need a plus in front of that decimal. So we know it's negative between these two values. When x is a member of between -8.42857 and -7.571 for 2, I'll put a 9. I'll have the 5 tell the 8 to round up to a 9. Acceptable bracket on that. When x is between these two values, this function is negative. And then we press answer to see if we're right. Let's have a look at the square root function. Positive and negative. The vertex is -7, -1. The A is positive and the B is positive, so it's opening something that looks like this. And we want to know when this is positive, so we're going to have to find the 0. When x is -7, the y value must be -1, is equal to 4 times the square root of the x value plus 7, close the square root bracket, minus 1, and that gives us -1. When x is 0, y is 9 point something. When x is -5, when x is -6, we have 3. When x is 2 and 11, 2. When x is 2, y is 11. When x is -3, we have 7. When x is -7, we have -1. When x is -6, we have +3. When x is -3, we have +7. When x is 2, we have 11. When x is 9, we have 15. But the parabola is going to look like this. When is it positive? From this point, from the 0. But we're going to have to calculate the 0. So we set the function equal to 0, and that gives us 0 is equal to 4 times the square root of x plus 7 minus 1. I want to get rid of that minus 1. I am going to add 1 to both sides. And that gives us 1 is equal to 4 times the square root of x plus 7. I want to get rid of the 4. That's multiplying the square root. I divide both sides by 4. That gives us 0.25 is equal to the square root of x plus 7. I want to get rid of the square root, so I'm going to square both sides. 0.25 squared is 0.0625, or 1/16, is equal to x plus 7. Subtract 7 from both sides to get the x alone, and that gives us negative 6.9375 is equal to x. When's it positive? Well, it's positive from that value when x is a member of, from that value until to infinity, and rejecto bracket around infinity. And then we press answer to see if we are right. That's it for sines. That's it for sines. Let's look at the axis of symmetry. In a function, it's the line x is equal to h. It's a line that reflects the graph onto itself. Let us go and have a look at some examples. I'm going to start with the parabola because it's symmetrical, and then we'll work our way back through the other functions and other graphs. If you're looking at a parabola, the axis of symmetry, let's quickly graph this. The vertex is at 112, like that, and it's opening up. So it's going to do something like this. Okay, so the axis of symmetry is going to be right here. X is equal to 1. It's a vertical line. In this case, x is equal to 1. I am going to graph this exactly just because I like to do that. When x is 1, the y value must be 12, is equal to 9 times the bracket x, the x value, which is 1, minus 1, which is 0, all squared is still 0, times 9 is still 0, plus 12 is 12. We have 112. When our x is 0, we have 21. So it doesn't look like that. It looks more like this. It's a little bit more vertical. At 2, we would also have 21. 2, 21. There we go. The axis of symmetry hasn't changed. It's still right here. It's still this vertical line. X is equal to 1. And then we press answer to see if we're right. All right, let's go and look at our other graphs very quickly. Graphs, axis of symmetry, level 37.
Find the axis of symmetry. Notice this is not symmetrical. There is no axis of symmetry in this case. There's nothing. Click on that, and then there we are. Let's look at another graph. Linear function. Here we have 10 over 3x plus 28. And you can argue that there's infinitely many axes of symmetry because this is an infinitely long line. It's an oblique line that's passing through the 28. And the slope is 10 over 3. So move over 3, up 10, like this. This is the line. This could be the axis of symmetry right here, right? Any perpendicular line to this is going to be an axis of symmetry. So there are infinitely many of them. There's no one axis of symmetry, or there's not. Null set. We could go to the absolute value axis of symmetry. So this has an axis of symmetry. It's going to be x is equal to the h value, negative 4. If we graph this, we have negative 4, 3, which is right there. It's opening up, negative 4. The y value is 20 divided by 3 times the absolute value bracket, the x value, plus 4, which makes 0. The absolute value of 0 is 0, times 20 over 3 is still 0, plus 3 is 3. Okay, if we look at minus 6 minus 7 is 23. Minus 7 is 23. If I went 3 in that direction, I went 3 in the other direction, that would be minus 1, would also be 23. It's going to keep going up. And they want to know the axis of symmetry. Well, the axis of symmetry is here, right? This is the axis of symmetry. It's this line right here. X is equal to negative 4, as we said. X is equal to h. And then we press answer to see if we're right. Let's go and look at axis of symmetry for the square root function. This has a vertex at negative 4, 0. It has a positive a and the b is positive, so it's going to do something like this. If I graph some points, it will look something like this. To get it exact, let's plot that. When x is negative 4, the y should be 0. It's equal to 4 times the square root of the x value plus 4, 0. When x is equal to 0, y is equal to 8. When x is 0, y is 8. When x is 5, y is 12. This is what our graph is going to look like. It's just going to keep opening up, and it's not symmetrical along any axes. There's no way that we can get a symmetrical curve off of this. There is no axis of symmetry on the square root function. So we'll put null set and answer. All right, so that's it for all of the properties. Have a good day.